So here we have another series of figures that presents a growth pattern, and we've been asked to find a function that predicts the number of blocks in each figure. And I'm going to look at these figures two completely different ways and get two completely different functions that model the number of blocks per figure. So just to refresh our memory, in our function we're going to plug in the figure number, which we will represent with the variable n. And when we plug in that figure number, we're going to follow some kind of rule recreate, and the output that pops out will be the number of blocks that create that figure. So for our series here, the first figure, when I plug a 1 into my function, I'm going to pop out 1 because 1 block creates the first figure. And when I plug a 2 into my function to represent the second figure, a 3 will pop out because there are 3 blocks in the second figure. And when I plug a 3 into my function to represent the third figure, and I follow my rule, 5 will pop out because there are 5 blocks that create that figure, and so on. So for the fourth figure, we will have 7 blocks, and for the fifth figure, we will have 9 blocks. So now we need to create a function that will correctly predict the number of blocks per figure. Now, the first way I'm going to look at this is to see my figure as a row on the bottom and then a stack on the top. So when I look at my first figure here, I'm going to see I have 1 on the bottom and then nothing stacked on top. So that would be 0 on top. So I have 1 block on the bottom and 0 on top. Then for the second figure, I would have 2 blocks on the bottom and 1 on top. For the third figure, I would have 3 blocks on bottom and 2 stacked on top. So for the fourth figure, I'd have 4 individual blocks on the bottom and a stack of 3 on top of that, 1, 2, 3. And for the fifth figure, I would have 1, 2, 3, 4, 5 blocks on bottom with a stack of 4 on top of that. So looking at the pattern I've created, there's no consistent number that I see in every single one of these patterns. But the numbers are changing in a consistent way. So one of the first things I notice is that my figure number matches the first number in my pattern. So when my figure number was a 1, I had a 1 in my pattern. My figure number was a 2, I had a 2 in my pattern. The figure number was a 3, I had a 3 in my pattern, and so on. So when I go to generalize this into my function, I'm going to plug a figure number into the function, and the very first number I want in my pattern is that exact figure number. Then I'm going to add something to that, and I can see that the number I'm adding, the stack of blocks on top of the bottom row, is always 1 less in the bottom row. If I had 1 in the bottom, there was nothing on top. 2 on the bottom, there's 1 less, there's 1 on top. 3 on the bottom, then there's 1 less, there's 2 on top. 4 on the bottom, yep, 1 less, that's 3 on top. So the amount that's stacked on top, so this is representing the stack on top, that's always going to be 1 less than my figure number. So I can represent that with the figure number minus 1. And just to recap, this n represented the bottom row. So here I have a function that can correctly predict the number of blocks in any figure. And I'm just going to check it with one figure. I'll check with this fifth figure right here. So when I plug in a figure number of 5, I better get a 9 as the total number of blocks. So I'm going to check that real quick. Now you'll want to check it with more than one figure just to make sure it's consistent. Sometimes you'll have a function that works correctly for the first 2 or 3 figures, but then doesn't work for the fourth. The function you create has to correctly predict the number of blocks in any figure. So checking figure 5, when I plug in a figure number of 5, my function says I'm going to have the figure number, 5, plus 1 minus the figure number. In fact, I'm going to put this in parentheses just to emphasize that this is one number. It's representing the stack on top. So I'm going to do the figure number minus 1. So this is telling me I have 5, that was the bottom number, plus 1 less than 5, or 4, that was the top stack. And together that gives me the 9 blocks that create the figure. Now there's another way we could look at this pattern and see a completely different function. So I'm going to look at this a different way, get a totally different function. So another way we could look at this is to see that we have one block in the corner and then nothing to the right and nothing on top. Then I had one block in the corner and one to the right and one on top. Then one block in the corner and 2 to the right and 2 on top. Then one block in the corner and 3 to the right and 3 on top. One block in the corner, 4 to the right and 4 on top. So now the pattern that I'm seeing over and over again would be 1 plus, in the first figure, I have 0 to the right and 0 on top, so 0 plus 0. Then the next figure, I still had 1 in the corner, plus 1 to the right and 1 on top. The third figure, I had 1 in the corner, plus 2 to the right and 2 on top. Fourth figure, I had 1 in the corner, plus 3 to the right and 3 on top. And in the fifth figure, 1 in the corner, plus 4 to the right and 4 on top. So by looking at the figures in this way, I see that I have a constant of 1 in every single pattern. That 1 represents the corner. So when I go to generalize my function is going to have 1 plus something, where that 1 is representing the box in the corner. So this is representing the box in the corner. So how are we going to represent the blocks that came to the right and to the top? Well, I can see that the blocks to the right and top are always 1 less than my figure number. When the figure number was a 3, I had 2 blocks to the right and 2 to the top. When the figure number was a 4, I had 3 blocks to the right and 3 on top. When the figure number was a 5, I had 4 to the right and 4 on top. So when I go to add this, I'm really adding 2 numbers. Here's a number and here's a number. So I'm adding these numbers, and they are always going to be 1 less than the figure number. Okay. So instead of just putting an n, I need to do n minus 1 to represent 1 less than the figure number. And I'm going to group that together to represent one number. Same thing here, n minus 1. So this is representing the blocks that were to the right of the corner, and this is representing the blocks that were on top of the corner. So I've created a function that looks completely different than the first one because I saw completely different geometry in my shapes. But this function should also work. So I'm going to check this one for the fifth figure as well. When I plug in a 5 into my function and crunch all these numbers, I should get 9 out because there are 9 blocks in this figure. So I'm going to plug in a 5, and my function says there's 1 in the corner, plus to the right there's 1 less than the figure number, so 1 less than 5, and on top there's 1 less than the figure number, so 1 less than 5 again. So I really have 1 in the corner plus 4 to the right and 4 on top, and adding that all together I get 9. So once I verify this function on a couple more of my figures, I can see that I've generalized another rule that will predict the number of blocks per figure.